Hello students, let's study about metals and non-metals in this video. As we know that the substances which are present around us, that means all the materials which are present around us, they can be categorized as pure substances and impure substances. Pure substances are the substances or those materials which are made up of same kind of particles. So we have to concentrate on these pure substances only. If these pure substances, they can be further classified into the elements and compounds. The elements are the pure substances which contain the same kind of atoms. So all those substances which contain the same kind of atoms, they are called elements. We will be studying elements in this chapter, metals and non-metals. The total elements known to us are 118, and these 118 elements, they are arranged in the periodic table according to the similarity in their properties. That means they are classified broadly in the periodic table as metals, non-metals and metalloids. Metals and non-metals, they show generally contrast properties to each other. That means properties which are exhibited by metals, they are not shown by non-metals, and the non-metals, they show some different properties as compared to metals. But if we talk about the metalloids, then the metalloids, they are also known as semi-metals, and these are the elements which show some properties similar to metals and some properties similar to non-metals. So we cannot call them as totally metals or non-metals. That is why we can call them as metalloids. The example are silicon and germanium. Let's talk about where we can find in the nature these elements. If we talk about the metals, since they are generally solid, so they exist in abundance in the earth crust, being solid in nature. The most abundant element or the metal found in the earth crust is aluminium, which is followed by iron. That means iron is the second most abundant metal which is found in the earth crust. The metals which are highly reactive, that means which react with the substances around it, and they are not, we cannot find them in the free state or the elemental state. They are always found in the earth crust in the combined state or in the form of compounds like sodium, potassium, aluminium and zinc. These metals are quite highly reactive metals. That is why they are found in the compound form, like in the form of oxides, sulfides and carbonates in the earth crust. Whereas the less reactive metals like gold and platinum, which are not reacting with anything, that means in general terms we can understand in them like that these metals, gold and platinum and silver, they are happy in themselves. They do not mingle with the other elements around them, so they do not want to react with any other element, so they are alone only. So that is why we can find them in the nature in the free state, or we can call it as the native state or the elemental state. Then if we talk about the non-metals, they can be, we can find them in the atmosphere as well as in the earth crust. Example like nitrogen and oxygen gas, we know that we can find them in the atmosphere, and they can also be found, we can also find nitrogen and oxygen in the earth crust in the form of oxides and nitrates. The sulfur, it is also, we can also find the sulfur in the free state as well as in the combined state in the earth crust, like sulfides and sulfates. Carbon also occurs in the earth crust in the form of free state, like the diamond, graphite and fullerene, which are forms of carbon only, and carbon can also be found in the form of compounds like carbon dioxide, carbon monoxide in the atmosphere, and carbonates and bicarbonates in the earth. Substances or the natural inorganic substances which are found deep under the surface of the earth, which contain the metals, they are called minerals. So what are minerals? Minerals are the naturally occurring inorganic substances found deep under the earth's surface is called mineral. And what are ores? Ores are actually those minerals from which we can extract out the metals easily and profitably. Those minerals are specifically called ores. So due to this, we can say that all the ores, they can be called as minerals, whereas all the minerals, they cannot be ores, because there are some minerals from which we cannot extract out the metals easily and profitably. Example which can be asked in the exam is, the ore of aluminium is bauxite and ore of iron is hematite ore. All the steps which are involved to extract out the metal from their ores, respective ores, like if we want to extract out aluminium from the bauxite ore, then the sequence of all those steps or processes involved to separate it in its pure form from its ore is called metallurgy. So metallurgy is the sequence of processes which is used to extract the metal in its pure form from its ore. Metallurgy, it consists of mainly three steps. The first step is concentration of the ore, where the earthly impurities from the ore, as we have got the ore from the earth crust, so that means the ore contains the earthly impurities like sand, mud, dust, pebbles, stones. So the removal of all these earthly impurities from the ore is called concentration of the ore. Second step is reduction. Reduction means the conversion of concentrated ore into the metal in its free state. So reduction means treating the metal ore, which is generally in the form of metallic oxide, into the metal in the free state. This is called reduction. The last step is refining. In the second step, we have got the metal in the free state, but that metal is not 100% pure metal, that is impure, that contains some impurities. So the last step for metallurgy is refining, which means the converting the impure metal into the pure metal. That means the purification of impure metal. This is called refining, which is generally done by electro refining. We have already discussed in the chapter chemical effects of electric current. So in the next part 2 video, we will discuss about the physical properties of metals and non-metals. Till then, happy learning to all of you and thanks for watching.